Good day, Doctor. My name is Cik Nurul Fatia binti Cik Muhammad Yunus. SA21007 is my ID number. The topic given of the assignment is search one scientific article that use voltammetry or amperometry for its application and then summarize its application and give the explanation. I found the articles of this assignment is the application of electrical impedance spectroscopy and amperometry in polyaniline modified ammonia gas sensor. So what is the amperometry? Amperometry, known as electroanalytical method, where a constant reducing or oxidizing potential that applied at a working electrode and give the resulting steady state current that measured. So the term of the amperometry comes from the measurement unit, which is the ampere, and the devices of the meter. The sensor utilizes polyaniline, which is PANI, nanofibers and employed technique such as electrical impedance spectroscopy with frequency response analysis and amperometry. This non-destructive chemical gas sensor was characterized by the high sensitivity ability to measure a wide range of concentration and give the reproducibility of the sensing data. For this research, we use ammonia sensing properties of PANI. We have two, which is electrochemical impedance spectroscopy and frequency response analysis, which is the electrical impedance analysis was conducted by using the Autolab electrochemical analyzer that equipped with integrated frequency response analysis software. For the second, we use the amperometric measurement, which is the amperometric analysis was performed by using same instrument, which is Autolab electrochemical analyzer that equipped with a general purpose electrochemical system software. For the cyclic volumetry was conducted over a voltage range between negative 0.3 volt to 0.35 volt at a scan rate of 0.05 volt per second by using 20 ppm of NH4OH solution to determine the appropriate potential. For the amperometric result, we have two equations, which is PANI react with the hydrogen chloride, produce PANI with the chloride. And then for the production of the first equation, it's react with the ammonia and produce the PANI with the ammonia chloride. It showed the suitable potential for amperometric study that inferred from the cyclic voltammetry that found to be 0.106 V volt. So we can see at the figure 2, which is the amperometric response is very well linearly correlated in the range between 2.5 until 20 ppm with squared correlation coefficient of 0.9944 with the conduction that increasing with the increase of the ammonia concentration. So we can see the RSD value percentage for the sensor is the 1.89. For the electrical impedance spectroscopy, we have two figures, which is figure 3A and figure 3B. Figure 3A, simple representative electrical circuit to model the experimental impedance data, which is R1 shows the contact resistance, while R2 and R3 shows the charge transfer resistance that effective at high and low frequency. And for the C1 and C2, it shows the capacitance also significance at high and low frequencies. For the figure 3b, it showed the Nyquist plot of 5 ppm ammonia of concentration. From this figure 3b, we can see a regression analysis on both semicircle produce the respective resistance and capacitance. It was calculated by the built-in program, which compares the experimental values to the best possible fit based on the circuit notation provided. So the values of the individual circuit components were adjusted to achieve the optimal simulated fit for the experimental curve. The changes in the resistance and capacitance components of the circuit setup showed linear or quadratic relationship with varying ammonia concentration, and the coefficient correlation is the obtained. For the conclusion, PANI is a conductive polymer in its emeraldine conjugated state necessitates the presence of a positively charged donor. For the contact, the polar protein entity fulfills the requirement, and then it changes in pH, which alter the donor concentration and then affect the system conductivity and impedance characteristic. This concept of electrochemical impedance spectroscopy, which is EIS, has been effectively implemented here for the first time using a screen-printed electrode system. So the experiment actually mapped the absorption of ammonia at the ppm level, correlating it with both the amperometric response and the impedance characteristic of the system. So that's all from me. Thank you, doctor, for watching.